Okay, so we've talked about dimensions and where they go and how they're placed on this document. So here I'm gonna show you some examples, kind of what we call dimensional drawings or working drawings. So these dimensional drawings or working drawings are pretty much what a final outcome of a object or some type of engineering project, whether that is being drawn, and they are based off of these two sets of standards: the American National Standards and the American Society of Mechanical Engineers. Those are the two most common standards used. You've kind of heard me talk about standards like, oh, why do we use arrows and not dots? Or, why those 16 rules of dimensioning, where do they come from? That's where all of this information comes from. So these working drawings applies for a couple of things. One, all working drawings, will have an object that is fully dimensioned or objects that are fully dimensioned. They will have an assembly of the actual object. So if multiple objects, let's say 10 parts make one object, all those 10 parts will be fully dimensioned in a front, top, and right side view. Okay, and then there'll be a drawing of the fully assembled part. Other things that might apply are parts lists. So what parts make up this object, how many are needed, what they're made from. Maybe, hey, what's the volume, what's the mass of those objects. Once again, that all depends on what company. Okay. So we've kind of seen working drawings, but we haven't seen like a full set of working drawings. Okay, like I said, a full set of working drawings, they're in a certain order with a title page, with the parts list, with materials, with dimensions. Each part is labeled and identified and fully dimensioned, front, top, and right side, or other views. An assembly, maybe how the part is assembled, called the exploded views. Okay, all of that is what this working drawing or dimensional drawing is. Okay, so this is what we're looking for. So the first thing here is a working drawing goes on a set of documentation, some title blocks, kind of like almost like a blueprint. So this is a title block we're going to be using. As you can see, it has our name as our class, and then it's got our logo in the top left, our bottom left. Now, other things that go in this title block are who designs this part, what the title of this part is, what the file name is. So if we were doing stuff in Inventor and we named it Cool Beans 2, that's what would show up, Cool Beans 2 on this document. It'll tell us how many sheets are in this working drawing. So as you can see, it's 1 of 1 on this. But if we have 10 sheets, so it'd be 1 of 10. The date will also be on here, so the date that the object was actually created would be on this, not the date that the object was placed in this. There's a difference. So if I made something back in 2015, but put it in this title block in 2018, it'll come up as 2015 because that's when I created that part. Okay. And then another thing that will pop up here is your ID will pop up in the bottom right hand corner based off of what computer you are using. So when you log into a computer, it's going to be that name. So the title block is used to identify companies, what project they are working on, who's created this project, who's working on it, what kind of files are they using, how many pages. All this stuff goes into play because we need to identify all of that. One last thing that I forgot to mention on a title block is usually a scale. There'll be a scale factor that pops up on this thing. So if we're doing a scale of like 1 to 2, that's half, or 1 to 3 is a third, depending on what our drawing is. So our scale is also on top of this. And I got some examples here in class of specific like engineering, civil engineering blueprints or working drawings that I have that are pretty neat that you can access as well. Now, the first thing I'm gonna kind of say here is the drawings that I show you on this presentation are just random parts. You can look as hard as you want online to look for a set of working drawings as a perfect example, but I couldn't, and you can't find one. And the reason why I'm saying that is because, remember, a set of working drawings has everything and all the dimensions that are needed to make an object or a product. So no company in their right mind is going to show everyone how to do something. For example, if John Deere, okay, they make tractors and things like that. If John Deere put a document out in the world that said that had all the dimensions, had the assembly, had all this parts identified as how they will make a $1 million tractor, everyone else would have the exact same thing. Everyone else would have the exact same thing, because why would they buy it when they could probably make it and sell it? Okay, so these examples that we're gonna find here are just random objects that I was able to find. As you can see, this one says this is from this Oak Ridge High School that I found online. Okay, so we're not gonna be able to find legit objects. The only ones that I'm able to find are things that are given to me personally that I cannot scan, that I'm not allowed to share on the internet because I am disobeying companies. So I have a big packet of a golf course in the room that you can look at. That has a set of working drawings. So as you see from this example, we have our front, we have our top, and we have a right side view. Now, for example, this student actually did this assignment wrong because of the way that this person, the way that Eric laid this out. Actually, no, he did it right. So what happens here, we have a front view, we have a right side view, and then we have a section view. Okay, you see here's our section view down here. So everything's got to be fully dimensioned. Okay, here's their title block that they used. Okay, sheet 1 of 1. It talks about what he saved this person as, what size they used it. It even says a B size paper. It says a date. Okay, all of this, and even the school that he used this for. So all these dimensions go on top of all these working drawings. Same thing here. This is the same person, Eric. We have a front view. We have an auxiliary view. And then we have a breakout view. An isometric. Once again, here's a brush holder. That's the title. That's the title of the actual engineering file. Sheet 1 of 1. Scale. Title, size of paper, username and date, and then of course the company. Okay, on this same thing, this is the same person, title block, front, top, and right side view of a part, all fully dimensioned, all nice and laid out with an isometric view. Here's something that is a little bit more intricate. This is a piston for a car. So what that means is this is used to ignite your cylinders in your car for the spark plug and everything. So these are attached and kind of rotate around. So this has a front, top, and right side view of what this piston looks like. And then they got some generic notes on what some of this information is and kind of how it relates. You know, what's the center of gravity. So we're going to find some on working drawings. We might find notes, okay, on some of these things. Center of gravity, maybe what the material is made from. As you can see, they use a title block, but this is on the bottom right instead of what you saw on the top right of the other one. Here's another one. This is a Geneva Convention. This is just a mechanism. So this is one part right here. This is another part. This is another part. This is another part. This is another part. And then this is another part. Sometimes we might find multiple parts on one sheet depending on their size. As you can see, that's all front, top, and right side views for this. With isometric drawings and fully dimensioned. Here's a Lego piece. Okay, Lego piece. This is kind of just something I found online as well. Here's an iPhone. I think it's an iPhone. This isn't like the legit thing because everyone would actually do this. But it's got multiple views. It's got a front. It's got a front here. It's got a right side. It's got a left side. It's got a top. It's got a bottom. It's got a backside view. It's got a detailed view right there. It's also got another detailed view here to here to show all these other measurements, and it's got some notes that you see on them. So this is fully dimensioned on one sheet of paper. Once again, this could all be on multiple sheets. Here is a Lego piece. Okay, we have a section view here. We have a detailed view of what the arm is so we can get our dimensions. And then we have all these dimensions that figure out the height with an isometric, of course, all on a title block. So title blocks are really important because it tells the reader, whoever's looking at this, once again, who's created it, what company they're for, what size are they looking at, what's the scaling, what are the measurements. The things that are not on this PowerPoint that I couldn't really find are parts list. So if we're going to do the parts list for this Lego piece, I know it would say, hey, we are using 2 hands that are labeled. So it'd be item 1, parts. There's 2 parts, 2 hands. They're the same. We probably have a part for the head, so that's 1 part for the head. 1 part for the legs, because the legs are actually, even though they're 2 legs, it's 1 piece. And then the body is 1 piece as well. So here's an example. This is a grinder, a hand grinder. This is a parts list. So we're looking here. We have our numbers of items. So they're labeled 1 through 13. We have how many of those items there are. So there are 2 number 1s. So we're pointing at this number 1 here. There are 2 of those. We have the part number. Usually it's an actual physical number or a part name. There's some type of description, like what it is, and then what kind of material it is as well. Sometimes we might add mass, how much mass the object is, how much volume, how much area. Once again, that kind of depends on the company. So this is a parts list. Okay, what you're noticing here is all these, what they're called the balloons. Okay, all these balloons are pointed specifically to a part of this assembly, and they're identified with the corresponding number, the quantity, the name of what that object is. So this is something we will be doing and looking at as well. If you have any questions, bring them into class.